So we've talked before about domain and range. Now we're going to take a step away because we've talked about domains and ranges of very specific functions. Instead of looking at a specific type of function, now we're just going to look at some graphs. Specifically, what happens if we have graphs that look more like piecewise functions? How can we figure out the domain and range looking at these graphs that are going to break apart? So, remember, domain is all possible x values, and the range is all possible y values. So if I look at my first example, and I have a bunch of different graph examples here, if I'm trying to figure out all the x values that this graph can be, I notice that this piece of my graph has an arrow, so I know this is going to go all the way down towards negative infinity, but it stops at 1, 2, 3, 4, 5, at a negative 5. So just this piece alone has x values, it looks like, less than or equal to negative 5. It's not a very good color, I apologize, to put on that graph, so let me change colors here. I'll change to the red. If I look at this piece alone, it looks like I'm at 1, 2, 3, negative 3. And then it looks like this arrow shows me that this keeps going. I believe that that is supposed to be an open circle. So since it's an open circle, I'm going to say this piece is x values greater than negative 3. So my domain for the entire function, it looks like it's x values less than negative 5, or equal to negative 5. So to practice my interval notation, I'm going to go, oops, I need a bracket. I'm going to go from negative infinity up to negative 5, unioned with, because I can or values can be on this other piece. It looks like I'm going to start at negative 3 and actually, hang on, let me back up. Negative 5 with a bracket, because negative 5 is included, unioned with a parenthesis, since it's an open circle, negative 3 up to positive infinity. If I do the same thing for my range, it looks like the range of this piece down here is y equals negative 1, and that's it. So for that piece, it's y equals negative 1, whereas for this piece, it looks like I start at a y value of 1, 2, 3, 4, and I continue up. Again, it's an open circle, so I'm going to say here I have y values greater than 4. So my range, again, I'm going to go ahead and write it in interval notation, is going to be y values, either y equals negative 1, unioned with starting at 4 and going up to infinity. So notice how I'm taking each piece and evaluating the domain and range of each piece, and then using that to give me my overall domain or range for the entire function. I have to be able to take this jump. Looking at my next example. So very similar. So let's say that I take each piece, and I'll start with my domain. It looks like the domain of this first piece here, and it does look like that's again an open circle, is 1, 2, 3. So it looks like it is going then shooting down towards negative infinity. So I'm going to go ahead and say it's x values less than negative 3. It looks like this piece here then is x values equal to negative 3 all the way to 3. So it looks like it's x is less than or equal to 3, but greater than or equal to negative 3. And this piece, it looks like I start at 3 and then I continue to go up towards infinity. So I am going to, as I do that, stretch across all these x values as this continues. All these x values will be used. So I'm going to say this piece is x values. It's an open circle, so I'm going to say greater than 1, 2, 3, it looks like. So putting that all together for my domain, I notice that I'm using all my x values because I'm using all x values less than negative 3, all x values greater than or equal to negative 3, and all x values greater than positive 3 or equal to positive 3. So I'm going to go ahead and say my domain, it looks like, is all real numbers, or in interval notation, it goes from negative infinity up to infinity. I have no missing x values, even though there's breaks in my breaks in my graph, I'm using all the x values. If I do the same thing now for my range, I'll start by evaluating the range of each piece. This looks like I have a y value of 0 here at an open circle, and then it extends down. So I'm going to say y less than 0. this whole line here, this is a constant function of y equal to 1, 2, 3. And then it looks here that I have y values that are greater than 1, 2, 3. So negative 3, because again I have an open circle, so I don't want to include it, and then it extends up. So again, doing the same thing, evaluating my range, it looks like I have all y values that are less than 0 and all y values that are greater than negative 3. Well, if I can have everything that's less than 0 and greater than or greater than negative 3, again it looks like my range is also going to be all real numbers, or if I choose to write it in interval notation from negative infinity up to positive infinity, again always using parentheses with infinity. I believe there are 4 graphs in total. Okay, so looking at the next one, doing the same thing, I'm going to start with my domain. So I'm going to look at each piece. So this looks to be the domain for x values of negative 1 from negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So it looks like x values less than or equal to negative 8, less than or equal to negative 2, because I notice it's not an arrow, they're just two closed circles. This piece here, I believe those are supposed to be open circles. So it looks like I'm between negative 1 and 1, 2, 3, 4, 5, 6. So this here is going to be x values less than 6 and greater than negative 1, but again not equal to because of the open circle. And this looks like this piece here is x values greater than or equal to 1, 2, 3. So analyzing this to find my whole domain, it looks like I can have x values that are between negative 8 and negative 2. And then it also looks like I can have x values that are greater than negative 1 and anything greater than 3. So I'm going to go ahead and say that my domain is, and I'll use a bracket because negative 8 is included. So from negative 8 up to negative 2, union with negative 1, and I'm going to say all the way up to infinity, since this arrow does continue going and I can keep getting bigger and bigger than 3. Doing the same thing for my range. If I look at the range of this piece, it looks like my y values are in between negative 1 and 1, 2, 3. So y is greater than or equal to negative 1 and less than or equal to positive 3. This piece here looks like y is equal to negative 2. And this piece here, 1, 2, 3, looks like, no, sorry, 1, 2, 3, 4, 5, looks like I have y values less than or equal to, I think I said negative 5 is what I counted. So now I'm going to take all my y pieces and put them together. So it looks like I can be between negative 1 and 3. I can be equal to negative 2, or I can be anything less than negative 5. So I'm going to start with my smallest value, and I'm going to say I can go from negative infinity up to negative 5 using a bracket there, unioned with a y value of negative 2. So this is how I'm going to show equal to negative 2 with interval notation, from negative 2 up to negative 2, unioned with from negative 1 up to 3, and these are also brackets. Negative 1 up to 3, and that would be my domain and range. Looking at one final example, this would be a good one for you to try on your own before we go over it. And before you try it on your own, I would say that these 3 are all open circles. This one's a closed circle. Now that you've hopefully had a chance to try it, I'm going to go ahead and say that this piece here looks to be x values less than negative 2. This piece here looks to be x values between 1, 2, 3. So negative 3 is less than x and is less than 1, 2. And this piece here looks to be x values greater than or equal to 2. So my domain, it looks like it can go anywhere from an x value of negative infinity, so I keep going down, all the way up to infinity. Since I'm negative 3, there is no gap in x values here, all these x values get used. And then same thing here. There's a hole here, but since it's filled in here, all those x values get filled. So my x values are going to go from negative infinity up to infinity. It is all real numbers. Doing the same for my range. I see that this has a y value. It looks like a maximum value of 1, 2, 3, 4, 5, 6, 7, 8. So it looks like y has to be less than or equal to 8. Remember, the maximum value of a parabola is its vertex. This piece here looks like y values between negative 2 and 3. And this looks like y values equal to negative 1. So, analyzing that, I can have anything less than 8, anything between negative 2 and 3, which is again encompassed in less than 8, and it can be negative 1. So it looks like if I just say that y has to be less than or equal to 8, I'll go from negative infinity up to positive 8. I will not use any other y values other than those. So, look at each piece individually and then try to put it all together. Some of you won't need to look at each piece individually. You'll be able to just do it as one whole. But if you're struggling with it, look at each piece and then try to, again, put that all together.